Hello, welcome to my channel. Most SAT students spend 5 to 7 minutes doing polynomial long division on every single problem. But what if I told you there is a 30-second shortcut? Your SAT math score depends on time. The faster you solve easy problems, the more time you have for the hard ones. I'm going to show you today the remainder theorem shortcut that will change your exam day. Here's the problem. Find the remainder when p of x equals 3x cube minus 5x square plus 6x minus 4 is divided by x minus 2. Now, if you're a normal student, you'd set up polynomial long division, and this takes forever. And you will make a calculation mistake somewhere. But here's what you are going to learn today. There is a very high error rate associated with polynomial long division. You are dividing, then multiplying, then subtracting, then bringing down the next term. You repeat it. It's tedious. It's error prone. It takes at least 5 to 7 minutes per problem. Imagine you're doing this 8 to 10 times in SAT. You have no time left for the hard problems. That's why there is a need for a better way. Let me introduce to you the remainder theorem. Now meet the remainder theorem. The rule is incredibly simple. If you divide a polynomial p of x by x minus a, the remainder is simply p of a. That's it. Just plug in the value and calculate. It's a 30-second process. It's not a 5-minute process. It's just a 30-second process. So let's go through the steps of following this. Identify the divisor. It's x minus 2. Identify the divisor. It's x minus 2. In this case, if I take x minus 2, that tells me x minus a corresponds to x minus 2, where a is 2. Now let us take an example. P of x is 3x cube minus 5x square plus 6x minus 4. I am going to plug in the place of x 2. Why? Because the divisor is in the form of x minus a, where a equals 2. And the remainder now is p of a. In this case, it is p of 2. Now, if I plug the value of 2 in the place of the variable, I get the value of p of 2. That is 3 into 2 cube minus 5 into 2 square plus 6 into 2 minus 4. So, if I simplify this, as shown, I am going to end up getting the remainder value p of a, in this case, p of 2, as 12. How much time did it take? Hardly few seconds. That's it. All we did was replace every single x with the number 2. No division needed. Now, this is where the magic has happened. We got the answer in 30 seconds. Now you might be thinking, how do I do this? Let me verify using long division. That takes 5 minutes. Well, you can verify using long division. You will end up getting the same remainder 12 after a tedious division process. But here, we got the answer in 30 seconds instead of 5 to 6 minutes. This is why the remainder theorem exists. It's not a trick. It's the smart, mathematically sound way to do this problem. Now let's see some common mistakes that students do. This will cost the students a lot of points because of these mistakes. Student sees the divisor x minus 2. Student sees the divisor x minus 2. Student thinks I'll plug negative 2 instead of positive 2. That's wrong. That's incorrect. Here's the correct way. X minus 2 means a equals positive 2. You plug positive 2, not negative 2. Similarly, If the divisor is x plus 3, I can write x plus 3 as x minus of minus 3. Now let us compare x minus of minus 3 with x minus a. A again here corresponds to minus 3. In this case, I will plug negative 3. I hope I'm clear. Common mistake 2. Order of operations. Some students calculate it like this. So they will do 3 times 2 equals 6, then 6 cube as 216. That's absolutely wrong. You must first do the exponents first and then multiply. You must first do the exponents first and then multiply. Here's the correct order. Exponents first. 2 cubed equals 8. 3 eighths equals 24. Exponents first and then multiplication. Do not multiply before the exponent. Let's take a real similar SAT example. This type of problem appears on nearly every SAT math section. Let me show you 2 real examples. In the first one, as we can see, p of x equals x to the power 4 minus 3x squared plus 2 is divided by x plus 1. Again, I can write the divisor x plus 1 as x minus of minus 1. Comparing it with x minus a, I clearly get to know that a here is minus 1. So what do? I just plug minus 1 in the place of x. So that becomes p of minus 1. That is my remainder now. So if I do that, I get p of minus 1 here as 0. Therefore, if p of x in this example 1 is divided by x plus 1, the remainder is 0. Done in less than 20-25 seconds. Let's take another example. When p of x equals 2x cubed plus 5x minus 7 is divided by x minus 3. Here, let me compare it x minus 3 with x minus a. A here becomes 3. So what's my remainder? I know my remainder is p of a. In this case, it is p of 3. And that would be 2 into 3 cube plus 5 into 3 minus 7. So 3 cube is 27 into 2, 54, plus 5 into 3, 15, minus 7. My remainder here is 62. Done in less than 20 seconds. Once you know the theorem, these become absolutely trivial. You can compare the time that is required to solve the same question using long division and using our remainder theorem. You are saving 5 to 6 minutes every single time you use this shortcut. On a SAT math section with 58 questions, even using this on just 10 problems saves you 50 to 60 minutes. Forget 10, even if you save it on 1 or 2 problems, every minute counts on the day of the exam. You are here saving quite a lot of time. This one shortcut can help you add extra points to your SAT score as it helps you manage your time better. Let me tell you why you absolutely need this shortcut. SAT math is a speed test. It's not about being a mathematician, it's about being fast. The remainder theorem is the fastest method available. Every minute you save on easy problems gives you more time on the hard ones. More attempted questions equals a higher score. Students who know this one shortcut often score 30 to 50 more points on SAT by just managing their time better. This one trick, 30 to 50 point gain. This is exactly what separates the student who score high as compared to students who score less. You now officially know the remainder theorem. Congratulations. But here's what's next. The factor theorem. It uses exact same principle as remainder theorem, except when the remainder equals 0. If you have understood this video, factor theorem will make perfect sense. But here's what I need from you. If this video helped you understand polynomial remainder theorem, like it and subscribe for more SAT shortcuts that actually work. Comment below I got it if the remainder theorem makes sense to you. And watch the next video on factor theorem. You don't want to miss it. Thank you so much for watching. I am MathFeeQuest 45. Here's my contact details if you need personalized tutoring. Don't forget to like this video and hit that subscribe button for more SAT shortcuts and math tricks. Good luck on your SAT. You've got this. See you in the next video. Thank you.